Dr. Fritz mentioned. Sorry about that. My name is Erica Hall. My project that I will be presenting on is called Growing an Airport, Creating More Connections to the North and Midwestern United States. So a quick overview. There are about 13,000 airports across the country, which seems like a lot, but we're only used to about 11% of those airports, which are known as primary airports. These airports, for example, would be Newark International, Philly, LAX, Seattle, airports that we would commonly fly out of when we're traveling either domestically or internationally. To be considered a primary airport, the airport needs to have commercial services, so United, American, Southwest commercial service flights. They need to be publicly owned and have at least 2,500 yearly enplanements. And then there are 4 types of primary airports, which are the large hubs, medium hubs, small hubs, and non-primary, which are the smallest. But for this project, we'll be mainly focusing on the smaller hubs. And I pulled all this data together. I wasn't quite sure what I wanted to do initially, so I just kind of made this map that you guys can see here and just spatially looked at it and saw that there were about 10 airports in the North and Midwest region that were small and isolated far away from pretty much any other larger airport. So I wanted to kind of investigate this. So I found these 10 smaller airports, which are Spokane International, Tri-Cities, Glacier Park International, Missoula, Montana, Bozeman Yellowstone International, Billings Logan International, Jackson Hole, Rapid City Regional, Hector International, and Joe Floss Field. And these airports are pretty far from any other larger hub, any medium hub. I created this 200-mile buffer, and there are only 4 airports that are within a 200-mile radius of these 10 airports that are larger or medium-sized hubs. These are Seattle-Tacoma International, Minneapolis-St. Paul, Portland, and Eppley Airfield, which just had a tornado the other day. Yeah, these airports are very isolated, causing travelers to have to travel several hundred miles to get to an airport that meets their needs. Additionally, in this region, and why it caught my attention, were all the national parks in this area. Some of them include Yellowstone, the Badlands, the Grand Tetons, North Cascades, Glacier National Park. And in 2023, there were over 17.8 million visitors to these national parks. So pretty big deal to this area. A lot of people traveling to go visit these national parks. And this image just right now shows the national parks. But in addition to them, there are also national monuments, historical sites, reserves, and recreational airports. So there are a lot of natural and historical areas to visit in this region, not to mention all the cities and towns that I wasn't able to include. So having a larger airport in this region would have a huge increase in value. There would be more direct flights, more commercial flights to this area, more destinations that could fly in and out of this airport, increase of visitors to these national parks and locations, and travelers wouldn't have to go so far to reach their airport or reach their destination. They wouldn't have to cross state lines to reach an airport, and same for locals, they wouldn't have to travel so far to reach their destination. So a little background research, a few things that I focused on is traveling farther to an airport, the idea that people have to travel several hours to reach their closest medium or large hub airport. Some reports or some articles read that there were over 2.5 hours. They drove 2.5 hours to their local airports. And they're doing so because these larger airports have the services and the flight frequencies that met their needs versus the smaller airports. And if these smaller airports were to have an increase in flight services, an increase of flight frequency, they would be more used by the locals and travelers alike. Additionally, with tourism, with flights people come into the city. So bringing travelers in from all over the country would make a significant impact on the economy. Additionally, with a bigger airport, people have to work, so that would also increase the economy of the local area. And then diving deeper into tourism are the national parks. As I mentioned, there's over 17 million visitors in 2023 alone. And that it seems to be a lot. However, there is a lack of diversity visiting these airports since it's so expensive to go out. People who have that income can, so marginalized population do not have the chance to go here. It's very expensive to travel out here between the flying and the driving. National parks are kind of not in the middle of nowhere, but they're farther out than from the cities. Also, as I mentioned, airfare prices with smaller airports, airfare prices tend to be higher. So one way to kind of combat this to really remove this is to introduce low-cost carriers, which are the Spirit Airlines, Avelo Airlines, increase more of those flight frequencies to these airports to increase the number of travelers coming in and out. And these would also have lower airfares for travelers. And then I wanted to do a little bit of background on the suitability analysis that I conducted for this report, combining multiple variables and creating a meaningful discussion, a meaningful result. And doing this with the GIS really gave me some suitability scores, so I was able to weight everything and get results from 1 through 10 of the most suitable to the least suitable airports. So I had 8 different types of data that was used for the analysis, plus the physical locations of the airports. So airport locations, just to help get the physical idea of where they are located. Then we have the 8 criteria, which are the yearly emplacements, the airport runways, which includes the number of runways and the length of the runways. We wanted to make sure we only use runways that could at least land a Boeing 737, which is one of the more common planes that are used for domestic flights in the US. The number of destination hubs, or the number of direct flights that each airport has, the number of commercial airlines that service each airport, whether the airport has international capabilities or not. And some of these airports either have their international capabilities on standby. Sometimes you would have to make an appointment to use the international customs. But anyway, as long as they had that international component, they would receive a higher score than an airport that had no international component. The population within a 150-mile radius, the road infrastructure, focusing more so on interstates around the airports, and then again, national parks. So just a couple images of the emplacements in the area. The bigger the plane, the higher the emplacements. And then just a quick overview of the interstates that go through this region and connect almost all of the airports, which is very important. So methodology. So a lot of this data really needed to be cleaned up. As I mentioned before, there's over 13,000 airports. So I got a big Excel sheet of over 13,000 airports. So I had to really dwindle that down to the primary airports from we saw on the first slide to just the 10 airports that I am focusing on. And then really needed to add the 8 additional criteria columns so that can be analyzed. So this is just a quick snapshot of that attribute table with all the final numbers that will be plugged into the suitability analysis. So straight into the runways, those needed to be dwindled down on based on the length of the runways. Not all of them had a runway of at least 8,000 feet, which is the minimum length required for a Boeing 737. The emplacement data did not need to be cleaned up. That was ready to go for each airport. Then we wanted to look at the destination hubs of each airport. So this is just a quick example a Rapid City Regional Airport and the airports that they fly to directly. So I counted these up for each airport. I also looked at the commercial airlines, which again just added up the number of airlines, commercial airlines that service each airport. Again, with US Customs and being internationally friendly, if there was some kind of international component to the airport, whether it being on standby or needing to make that appointment, they would receive the score of 1 versus a score of 0 of having no international capabilities. We're looking at the general population, even though it is a general population and not everyone within the 150-mile radius would be flying, it gives a very general idea of the catchment area or the number of people that could be utilizing that airport. And we chose 150 miles because that is about a 2.5-hour drive at 60 miles per hour, which in one of the articles from Literature Review estimated that that was the average time that people would drive the furthest to drive to an airport. So we wanted to use that number. So the population within each 150-mile boundary was totaled, and this crossed into different state borders than just the original 5 states of where the initial 10 airports were located. And then we did a 5-mile buffer around each airport for the interstates. This was obviously there's going to be smaller roads to get from the airport out to the interstates, and having that transportation infrastructure is very important because it's harder to get to an airport, it's less accessible, and not as many people can get to that airport versus having the interstate. Then we looked into which airports were closest to national parks. The closest an airport is to a national park, the higher score they would receive. Once that was all cleaned up, we did the suitability analysis with the business analyst tool licensing. We had to weight all of the data. So for the first analysis, we did a weight of 12.5% across the board, just to get an initial idea of what the results would be as a first time. And then we get our results. So results number 1, we saw that Spokane International came in first, and Bozeman Yellowstone ranked second. And this is a little different than I initially thought. I initially thought Billings Logan International would score higher just because that was the one airport that I knew, and I knew there was a city nearby. But we dig in a little deeper, it kind of makes sense that Spokane and Yellowstone rank higher. Yellowstone is very close to Yellowstone National Park. Spokane wasn't close to a national park, but it also ranked higher in other scores, such as the number of destinations they fly to, the number of commercial airlines they fly to. So it was really interesting to see what parts each airport ranked higher and lower. Then we ran the analysis again and did different weights. So we picked 4 criteria that were ranked high or weighted higher. And these were the runways, since having multiple runways helps to relieve congestion status on the tarmac. There was the interstate, because interstate having that infrastructure to get to your destination after the airport is very critical. We have the destinations, and then we also had the international flights rank higher or weight higher. And then population, the emplanements, national parks, and the commercially serviced airlines were ranked lower. So unfortunately, they did not have much of a different results from the first one. Spokane and Bozeman Yellowstone continued to rank higher, the highest out of all of them. Here is the final results for everything. Is that everything scored pretty much consistent The biggest takeaway from running the analysis twice was that the top 4 airports for both analyses stayed the same, and whether the criteria was weighted equally or varied, those 4 airports obviously hold some important criteria that keeps them on top and gives them more of a reason to be expanded. So looking at future research of what I wasn't able to accomplish with this project is looking into different types of population. For this project, I just used general population, but I think if we could look more into education level or socioeconomic level, those who have more of an expendable income, who has the means to travel more so for leisure, those would be more interesting to look at. Also identifying the yearly visitors to national parks. This won't really impact all of the airports since only 8 airports were within a close distance of the national parks. But it'd be interesting to really see how many people go to each national park and the closest airport to that. Having available land around the airport is very important for expansion. If there's no land around the airport, they cannot expand, they cannot add additional runways. And then testing different weights. Obviously, some factors are more important than others, such as the number of current runways surrounding land. That would be something weighted much higher than, let's say, the number of commercial airplanes that are currently servicing. So finally, overall, this capstone was to explore the airports located in the rural North to Midwest. This is a very vast and widespread region, but there is a lot to it, a large population, a lot of destinations, and a lot of national parks. 8 criteria were identified, and we were able to define over 2 analyses that Spokane International Airport and Bozeman Yellowstone International Airport seem to have the best qualities to be expanded into a larger airport for that region. My bibliography. I will head to the chat.
All right, Erica, thank you very much. Great presentation.
Thank you.
I'll wait for some questions to come up in the chat window, but oh, it looks like you have a question already.
Yes, so the first question is, did you consider incorporating origin destination survey data provided by the US DOT? I did not. Would this be specifically for driving or flying? Flying, it did not occur to me, just because I was more focused on the direct flights of what was of what the airlines currently do. I know you could do a lot of transfers to airports that go into these smaller airports. But no, I did not initially look at origin destination. That would be good for future research and learning where the travelers or the visitors to the national parks come from to really get a good idea of that. Oh, sorry, my cat. But no, I did not look into that, but that is a good idea. The second question I have is, which important criteria do you think cause the results not to change? Could you talk a bit more on this? Yes, I can. I think some of the biggest criteria that caused it not to change was the international aspect, since it was an all or nothing. And I think all but all of the top 4 airports had international capabilities. One airport, I'm not sure. But I think that was a major impact, and the number of runways, I think, was majorly important. There were a couple that only had 1 or none. The next question, how did you determine the weights for the variables. You mentioned having land surrounding the airport was weighted the highest. So for the first analysis, I just did 12.5 across the board since that equaled the 100% weighting. So that was kind of just a given first test run, making sure everything was running and just to get an initial idea. For the second analysis, I kind of had an idea of what criteria were more important, such as runways. If you have multiple runways, you're going to have less congestion on the airport tarmac. If you have that international capability, you're going to be able to get flights from Canada. Some of them, I just kind of made my best educated guess of what would I look for in an airport. And I didn't have the surrounding land in my actual analysis, unfortunately. But yes, that is one thing I saw in almost every report when discussing expanding an airport is having that land available. I have a friend who's also working at BWI, and they're looking for buying up land all around the airport so they can also eventually expand and extend their runways. So had that firsthand experience of how important it is to have as much land as possible to really spread out, build runways, and have as much space as you need to instead of being bumped up, such as Reagan National Airport, which has 2 small runways, such a small plot of land, and it's right on the river. There's not much expansion they can do, but they are still awfully busy. Anthony Robinson sent data. Awesome, thank you. Tim mentioned that he lives in Missoula and can tell us that the airport is in the middle of a large expansion. That is interesting because I'm not sure if that was in one of my top 4 airports to grow.
All right, well, thank you for your responses to the questions, Erica. If you could put your contact info in the chat window, so if someone has a follow-up question, they can contact you.
Sounds good. Thank you so much.
All right, Sarah, if you want to start sharing your screen, we can make sure your presentation shows up. All right, we see your screen. So whenever you're ready, you can go ahead.
Okay. Yeah. I just want to say that I got aligners in, so, and it's kind of giving me a lisp, so I just want to apologize in advance if I stutter. But yeah, hi everyone. Thank you for coming to my capstone presentation. This project investigated the variables influencing urban heat island intensity in the US. So before we go into my project, I think it's important to understand what are urban heat islands effect, and they're basically heat islands are urbanized areas that experience higher temperatures than the outlying areas. And so why is this an issue? They cause adverse impact on human health and the surrounding environment. They lead to increased energy consumption, elevated emissions of air pollutions, increased instances of heat-related illnesses and death, and impaired water quality. So while looking at the research, I found that while there are a lot of studies on the drivers of urban heat islands, most of them are limited to a single city. And so what do I propose? Well, I'm looking to identify and quantify the key variables associated with urban heat island intensity and assess how these variables vary spatially and temporally within different cities in the US. And urban heat island intensity for this project is characterized by increased surface air temperatures, land temperatures, or temperature anomalies. And for my analysis, specifically, I'll be focusing on temperature anomalies. So what does the literature say about the current variables? I found that it came down to 4: impervious surfaces, vegetation, demographics, and climate. So impervious surfaces consist of pavements, roads, and other indications of human settlements. Numerous studies show that impervious surfaces increase urban heat island intensity by trapping heat within the city, and they mainly do this by reducing albedo. They also degrade the surrounding environment and reduce urban green space, and research does support that impervious surfaces is a good method for predicting urban heat islands. Vegetation. So although the significance of vegetation does vary based on their type, generally canopy coverage was found to be the most significant in reducing the surrounding surface air temperatures. These include by increasing albedo, facilitating evapotranspiration, which is a combination of evaporation and transpiration. They create shade, diminish heat absorption, and filter pollutants. The EPA also recognizes this impact and documents canopy coverage as an effective strategy to reduce urban heat islands. So I think it's a key variable associated with urban heat islands. Demography. Generally, larger and denser cities tend to exhibit heightened urban heat intensities. And then also communities of color and low income are positively correlated with increased urban heat island intensities. Some studies also found there to be lasting impacts from historic redlining practices. And then finally, climate factors such as precipitation, humidity, and spatial and temporal patterns significantly affect urban heat. Current research indicate that rain can slow daytime temperature rises, but also reduces nighttime cooling. Geographic location also has an impact. Cities, usually within drier climates, have higher nighttime urban heat island, while tropical cities tend to have lower urban heat islands. So yeah, my project aimed to address the questions, again, of which variables are associated with urban heat island intensities across the US. And then to do that, I used the NOAA's Urban Heat Mapping campaign, which is an ongoing nationwide effort to collect urban heat island data in all 50 states. And so the image is just showing where all the cities that they've collected for the last 6 years. And this is a volunteer-based campaign. Volunteers would collect temperature data using car and bike mountain sensors, and they would collect morning, afternoon, and evening temperature in one day during the summer month. And then their data was combined with satellite data to create detailed maps of the urban areas most impacted by heat. So within their data set, it includes temperature readings and temperature anomalies. And temperature anomalies is a neighborhood temperature compared to the citywide average based on Kappa strategies, which is another initiative started by NOAA. They include impervious surface percentage, canopy coverage percentage, and demographics, such as total population, minority, medium income, and poverty. And this is just a screenshot of the urban heat mapping campaign downloaded onto my Arc Pro. This is a heat map of Washington, D.C. and their surrounding neighborhoods, and it's based on temperature anomalies. And then the bottom is just a table holding all of the relevant data. So I wanted to create a model for each city and their respective climate types. I ended up choosing DC, Detroit, Michigan, El Paso, Texas, and Miami, Florida. These cities were chosen to show a diverse range of climates in the US, and they all had a sample size of at least 30. Predictor variables for the model are impervious surfaces, canopy coverage, total population density, and median income. I calculated total population density by dividing the total population from the land area. And these 4 variables represent heat-absorbing urban surfaces, vegetative land cover, city size, and socioeconomic status. Afternoon temperature anomaly was used as a dependent variable. And again, this represents urban heat island intensity in that it represents neighborhood temperatures during peak heating hours relative to the citywide average. And then exploratory data analysis was used to determine an appropriate model. And then all of the statistical analyses was automated using Python for each cities, and maps were created using ArcGIS Pro. For the exploratory data analysis, I wanted to see if ordinary least squares model was an option first. Ordinary least square is a common technique for estimating coefficients of linear regression equations. But this model might not be ideal if my data violates any of these assumptions, which is linearity, homoscedasticity, independence, normality of error, and no multicollinearity. And then I also went into this project thinking that there would be some sort of spatial dependence in the data. So I also conducted a spatial autocorrelation test. So the first thing I did was test for normality using a Shapiro-Wilks test. I tested for normality on the raw data after the outliers were removed and after transformations were applied. For the Shapiro-Wilks test, p-values greater than 0.05 indicate a normal distribution. So I chose data sets yielding the highest p-values. Like in some cases, I transformed data and they actually led to lower p-values. In that case, I just used the data with the outliers removed. But all of the data sets had outliers removed regardless. And then outliers were calculated using the interquartile method. Any data outside of the upper and lower bounds were considered outliers. And if they were still non-normal, I went ahead and transformed them based on their skewness. For heavily skewed data, a log base 10 or an exponential transformation was applied. For moderately skewed data, a cube root or square root transformation was applied. And then the table on the bottom left is an example of one of my normality test results. And normally distributed data sets are denoted with an asterisk, but none of the data had all variables normally distributed. That's for DC, but none of the cities had all variables normally distributed. Because none of them were all normally distributed, I went ahead and ran an ordinary least squares regression to look at the residuals. I did both a visual inspection of the scatter and residual plots, and I also did another Shapiro-Wilks test on the residuals. And if you look at the residual versus fitted plot on the right, you can see that median income is randomly scattered around 0, while tree canopy has this cone-shaped pattern. And that's pretty indicative of heteroscedasticity, which is another violation of ordinary least squares. And then again, the table on the bottom is of DC. It is kind of representative of what I saw for each city. Some of the residuals were normally distributed while some were not. But there was very little linearity for each variable. In fact, DC had the highest R-squared values out of all the cities. And because no one city had all normally distributed residuals, I went ahead and conducted a spatial autocorrelation test on the residuals. This again tests for spatial dependence. And the spatial autocorrelation test was conducted using a k-nearest neighbor spatial weights matrix. K-nearest neighbor was used because it uses Euclidean distance, so no features needed to be right next to each other. And then, yeah, the spatial autocorrelation reports a Moran's index value and its associated p-values. A positive Moran's index means that observations that are closer to each other are more similar, while negative Moran's index means that observations that are farther away from each other are more similar. And as you can see, all cities had highly significantly positive spatial autocorrelation present in the residuals, Miami had the most positive spatial autocorrelation present, while El Paso had the least positive spatial autocorrelation present. So this was really the big evidence against using an ordinary least squares model. Although some variables violated the assumptions in earlier tests, such as low linearity, non-normally distributed residuals, all cities and variables really violated the assumptions of independence due to the presence of spatial autocorrelations. So because I know that ordinary least squares is not the ideal model, or likely not the ideal model, I chose to go forward with two options, which is spatial error regression and spatial lag regression. Both account for spatial dependence in the model, but in different areas. Spatial error regression, the spatial dependence is accounted for in the residuals and is reported by the lambda value. And the lambda value is very similar to the Moran's index. This model also reports a pseudo R squared value, which is like a regular R squared value, but it's used when a traditional R squared value cannot be calculated. Pseudo R squared value calculations are different for each model, so it shouldn't be used as a comparison between different model types as an indication of model fit. So instead, the model fit is measured by the AIC and log likelihood. And for my analysis, I'll be focusing on the AIC value. Values closer to 0 indicate a better model fit. For the spatial lag regression, spatial dependence is accounted for in the dependent variable and is reported by the spatially lagged dependent variable. This variable is influenced by predictor variables and by the neighboring dependent variables based on the spatial weights matrix. So in our case, temperature anomalies that are closer to each other are weighted higher. This model also reports a pseudo R squared value and a spatial pseudo R squared value. Spatial pseudo R squared value just accounts for the spatial dependence. And again, model fit is measured by the AIC and log likelihood. So here are the model comparisons by city. Ordinary squares on top, error regression is in the middle, and lag is at the bottom. This is DC and Detroit. The spatial error regression was a better fitting model for DC, El Paso, and Miami. Detroit preferred the spatial lag based on the AIC values. If you look at all three models, AIC was the highest in ordinary squares for all cities, with the lowest AIC value being in the spatial error or spatial lag model. And this is just for El Paso and Miami. And so in summary, impervious surfaces is positively correlated with afternoon temperature anomalies in DC, Detroit, and El Paso. Tree canopy is negatively correlated with afternoon temperature anomalies in DC only. And then medium income is negatively correlated with afternoon temperature anomalies in El Paso. But very little of the variation in the dependent variable is explained. DC had the highest with impervious surfaces and tree canopy accounting for 49% of the variation, while Detroit, El Paso, Miami all had R square values explaining less than 10% of the data. The lambda and the spatially lagged dependent variable also all came back positively significant, indicating that there is still some kind of spatial dependence in the model. So these are the predicted versus residual plots for each cities, respective to their best fitting model. I also included some satellite imagery at the bottom for reference. And for the predicted maps, the red shades are higher temperature anomalies, while blue shades are lower temperature anomalies. And in the residual maps, over predictions are indicated by pink shades and under predictions are indicated by green shades. And here are the ones for El Paso and Miami. Miami actually only had higher temperature anomalies present in the predicted values, so those are indicated by the orange and red shades. So out of all of these maps, Detroit actually looked the most random, but all of the cities had some spatial clustering present in the residuals. Conclusion, again, I'm redefining the purpose, identify and explore key variables associated with urban heat island intensity across 4 cities using regression analysis, and these are based on their climate types. And then spatial error regression and spatial lag regressions are a better fitting model compared to the ordinary least squares. Impervious surfaces is significant in 3 out of 4 cities. Tree canopy and medium income is significant in only 1 city. Impervious surfaces kind of aligns with the literature where it's shown that those types of surfaces are a good predictor of urban heat islands. I was a little bit surprised about tree canopy though. But population density ended up not being a good predictor of urban heat island intensity in any of the cities. There are still some spatial clustering that is not being captured in the model based on the residual plots. And there's also generally a lot of noise in the data. This is indicated by the low coefficient but significant p-values. And that could mean that afternoon temperature anomalies are pretty unpredictable or there are key variables missing. I'm kind of thinking that it's the latter just because urban heat islands are pretty multifactorial. And then going forward, I think it would be nice to have more research into the predictor variables, maybe have it more localized to each cities, just so we get more accurate results. And then I would also like to use more temperature readings over a longer period of time, just because the NOAA data only collected temperature readings for 1 day. That's it. Thank you. Any questions?
All right, Sarah, thanks. Great
Mhm.
presentation. While people are writing some questions, I'll ask one. So in your list of predictor variables, you had median household income and I've talked about this a little bit before. So what was your rationale for including that variable? And then even though it was significant in one instance, what perhaps other variable would you have considered in its place?
Yeah, so I was specifically looking at some research that talked about redlining, which includes socioeconomic status and race-based discriminatory practices. So I was just pretty curious about that just because there is some research into it. And it was significant for El Paso, Texas, which I think that could probably be some historic redlining present. I would like to maybe substitute it with maybe more different demographics data, maybe poverty or some like minority data that was in the data set. Did that answer
Okay.
your question? Yeah.
Yeah. No, I just want you to kind of reflect back on those decisions. So yeah, good job. Looks like you do have a question in the chat window.
Yeah. Gregory, excellent description of your analytic methods and exploratory data analysis. Do your results support your original hypothesis, if any? I was a little surprised that tree canopy wasn't as significant, just because it was a pretty big variable, and there's a lot of cities that plant trees to help mitigate urban heat islands. Um, I am kind of thinking that maybe like El Paso, they're pretty deserty, so maybe the vegetation that they have there doesn't have that much shade. Um, and then places like maybe Miami, where there's a bunch of tourism, there could be like other variables that are influencing afternoon temperature anomalies. So, I mean, the impervious surfaces, definitely. I definitely thought that was going to be significant, but all of the others was a little bit surprising.
All right. Well, thanks again, Sarah. If you could put your email in the chat window, if someone has a follow-up question, they can contact you.
Sure. Thank you.
All right. Next up, let's go back and pick up Ryan. So if you want to start sharing your screen. All right. And we see your slideshow.
Okay, can you hear me all right?
Yes, here you're fine.
Okay, perfect. So
Yeah, you can start whenever.
okay, perfect. All right. So good afternoon. My name is Ryan Johnston. This is my presentation on the development and evaluation of a prototype hazard dashboard for Army Reserve facilities in the southwestern United States. So a quick agenda. We'll go over the introduction, goals and objectives of my project, some of the relevant literature, and then currently available solutions and how they don't really fit the needs for my division. Talk about the user testing and methods I did to develop our prototype dashboard and report that goes along with the dashboard. Talk about some of the data and methods for the dashboard itself, and then a conclusion and kind of future considerations and work to finish off what I started in the project. So again, my name is Ryan Johnston. Currently, I'm the company commander for the 63rd Readiness Division. So this division is an Army Reserve division that manages all the Army Reserve infrastructure in the southwestern United States. So California, Nevada, New Mexico, Arizona, Texas, Arkansas, and Oklahoma. So as you can imagine, with such a large region and a varied region, a lot of the infrastructure that we're in charge of is subject to varied hazards and weather, constantly changing and simultaneous. So we run into a lot of problems with communication of issues for the facilities we manage. There's about 330 facilities across these 7 states that we're in charge of. And so currently we don't have a good way to monitor changing hazards or to identify potentially affected facilities and kind of start planning for a response to the hazards that might be affecting those facilities. So the goals then of my project would be to conduct a needs assessment within the division for the personnel who would kind of do this hazard analysis and information distribution, do user testing for a prototype dashboard and a report that they would be able to utilize to communicate these issues to our commanding general and our public works so that they can kind of see what facilities are currently affected and kind of start planning or at least coordinating with the facilities to see how much damage they may or may not have suffered. So current literature on I broke the current literature down into 2 different parts. So focused specifically on mapping dashboards and things for military usage, and then just general mapping and dashboards for hazard and disaster response. And what we see is a lot of the military focused literature that's out there is really kind of looking at individual soldier tracking in the midst of battles or operations, trying to provide additional information to commanders about where personnel and equipment is. So looking into developing, alternate reality and heads-up displays that go along with a map and a dashboard to just give as much information about an operation as possible. Not really anything that's applicable or useful for my division for our needs for infrastructure analysis. And then very similar story when we look at just the general literature on dashboards for disaster and hazard response. a lot of agreement on the importance of using web maps and dashboards for situational awareness for decision makers, how it can lead to shorter decision making times, and help with response. But again, a lot of the focus is on tracking first responders in the midst of a disaster response, and not really focused on kind of the big picture analysis of what infrastructure might be affected by what disasters, and then how to kind of respond to that in a more general, let's say, like policy setting or funding and repair kind of way. I can only find one paper kind of focusing on that, and that was this paper by Arianto that talked about earthquakes in Indonesia and looking at road infrastructure affected by earthquakes. And what they found was that making that data available in like a web map was pretty useful to help people plan traveling, and also to help businesses and other things plan kind of like transportation of goods and stuff to avoid affected areas. So we see in the literature that there is use for this kind of dashboard, but no real focus on developing anything either for general use, disaster response, or for the military. And so it's a lot of the same when we look at available solutions that the military currently uses. The two biggest ones being the Command Post of the Future, and then the Android Windows Team Awareness Kit. So again, both of these systems developed for military usage for mapping and kind of analysis of operations and soldier tracking. They don't really provide us with what we need as far as data analysis or infrastructure and kind of like hazard display. They're really, again, just focused on where is a soldier, where is equipment on a map during some kind of operation or something. The only thing that the military has currently that kind of meets our needs is the Joint Engineer Common Operating Picture. So this is an ArcGIS online dashboard. Currently, we do use this for wildfire tracking, but it doesn't have a lot of the weather and hazard information that we need. It doesn't really have any built-in data processing or analysis, and we don't have any way to manage it ourselves. It's managed by the Army GIS. And so if we could get all the weather and other hazard layers we need added to this map, it could potentially fill the gap that we have. The only significant issue with it is it has hundreds of layers. It's really the one map or web map dashboard for the contiguous United States for the military. So there's hundreds of layers in it. It's very slow to load. So even if we could get our layers added to it, it wouldn't be the ideal solution, just because of the time it takes to kind of sift through it and get the information out of it that you need. So what I did for my project then is I developed a prototype dashboard wireframe and a prototype hazard report. I did about 1 to 2 weeks of testing with 4 different users. And so according to Nielsen, 4 users should be sufficient to identify around 80% of the potential issues with my dashboard. So I'm satisfied with just the 4 users that have identified the majority of the potential issues with the dashboard. And then because these are all military personnel, there's specific requirements to fill these roles. So I know that the personnel who I had test the wireframe are also pretty representative of potential future users of the dashboard. So this was done via one-on-one interview. I had a series of questions that I had them answer utilizing information from the wireframe, and then I had them create a prototype report from the wireframe. And I kind of watched and noted issues or difficulties they were having, or where they kind of failed to get the proper information that that was required. And so they had this prototype dashboard on one computer monitor. It functions exactly the same as the actual dashboard will function on the web. It's made in PowerPoint. Everything is clickable, so as you click through it and utilize the UI, it provides you information about facilities, hazards, and then a list of what facilities are actually currently affected by the hazards. And then they utilized that to answer my questions, complete this prototype hazard report. And then we did, after that, we did some one-on-one discussions about what would have been useful to, add to the dashboard, or what would have been useful to add to the report, what was missing, and then just a general needs assessment. Is this something that's still needed for the division? And so kind of the results I got back from that is there's definitely still a need for the dashboard in the division. They get requests from either our commanding general or from Army Reserve Command about facilities and hazards and weather and stuff sporadically, but frequently. And then because they don't have any one place to gather all this information, and they don't have a standard report that they provide based on the information, it really takes them, it takes somebody about a day to go through all the different sites and places, gather all the information, build a report, and then send it up. So having this dashboard, having the report would significantly cut that time back, to minutes. And then also we would just be more aware, I think, of a lot of stuff that we're currently missing, because right now it's very reactionary. They wait for somebody to ask a question rather than kind of having something readily available that they can check and see where there's facilities that are being impacted currently. Some of the actual issues that I noted with the dashboard uses itself, 3 out of the 4 personnel who tested the wireframe didn't utilize the information panels at all. So there's an information panel to the right and bottom. They kind of just relied on the symbology and themselves reading the map to try to identify what facilities are affected or what hazards were where. And that also led to a lot of incorrect information on the prototype report, because the default symbology in the hazard layer was very poor. And then for the prototype report, they just identified a lot of missing information that they get regularly asked when there's hazards. So the status of a facility, impacts to workers, are there any other reserve soldiers in the area that might be affected by the hazard? And so in response to this, in the actual web dashboard prototype, when it gets published, updated the symbology. So a big issue with the symbology is the default symbology accounts for about 120 potential hazards. So we reduced that down to about 12, and then utilized Color Brewer to get a good color scheme for 12 different unique IDs. And so that way we're able to reduce a lot of the similarity and issues with the default symbology. And then we updated the report. I added additional columns for the information that had been requested. So number of employees, work status, facility status. And then I made the legend collapsible on the dashboard and put a static legend to the right of the report. So that way the legend on the web map isn't blocking any of the map itself. And then finally, I updated the splash screens for the dashboard. So now when you load into the dashboard, you get a couple different splash screens that highlight the information panels themselves, kind of talk about the usage of them. And so hopefully this way, it'll increase the user's awareness of the information panels, and they'll utilize those more than trying to just read the map themselves and potentially get incorrect information. So as I move forward and begin to build the prototype dashboard, I'm going to build it with a light gray canvas base map, thematic layers for wildfire information, a buffer for the wildfires to kind of identify the affected areas, and then the weather service hazards layer that we'll utilize to visualize the hazards. So this is all going to be done with Esri's JavaScript API, mainly using the query function to locate relevant wildfires and National Weather Service warnings, and then buffer the relevant wildfires so that you can identify the affected areas, and then just do a secondary spatial query on the weather service layer and the wildfire buffer to actually identify the facilities that fall within the affected wildfire area with those National Weather Service watches, and then highlight those affected facilities. Very quickly identify where the issues might be. So then for conclusion and future considerations for this, so most of my project, the focus shifted from actually developing the dashboard itself to doing a lot of the evaluation. So we did a lot of evaluation, user testing, and analysis on a prototype web map dashboard. The dashboard is going to provide real-time weather, hazard information, identify affected facilities, and then allow personnel to quickly build a report of the hazards and facility statuses, and then publish that to the general, our public works department, other people who might need to know what facilities are being affected by what hazards. So moving forward, I have a lot of the individual script and pieces done for the dashboard. I need to synthesize everything, get the dashboard finished and published to the web, and then we'll probably spend a couple months utilizing that to build the report, publish this information, and then hopefully sometime in the future I'll be able to present this at one of our readiness division symposiums. So every 6 to 12 months, all the readiness divisions get together and share kind of lessons learned and some other new practices that they've come up with. And so if I can run some more time testing this dashboard, I'd like to present it there so we can kind of get all the divisions on the same page, utilizing something similar for infrastructure management and hazard analysis. Thank you. Are there any questions?
All right, thanks, Ryan. Great presentation. While we're waiting, looks like you have a question in the chat window. So if you probably stop sharing your screen, you can probably see the chat window.
Yeah, sorry, 1 second. Do you want me to read the questions out loud? Okay, so
yes, if you would, that'd be great.
Yeah, nice job, Ryan. Curious about test users' reaction to a project like this that one of their peers chosen to take on. Were they hopeful about the results of the project? Do you think there would be any value in having non-military personnel take a look at this to see if there are different opinions that might be worth noting? Yeah, so I think so. The people that I tested it with weren't aware that I was doing it. My supervisor was aware because I had originally done this 2 years back just for wildfires, because we were doing something similar for wildfires. It was taking us a long time to produce the report on wildfires we were doing, and so I built something similar, a dashboard just for that. So it was after using that that me and him decided we were going to expand it to hazards overall. But in that time frame, kind of, he left the department. I transferred to a different department. So nobody there was really aware that this was going on for hazard development. So yeah, they were surprised. They were definitely hopeful, I would say, because like I said, usually it takes somebody about a day to gather all this information. They're going to, you know, weather.com, NWS, and all these other places to try and find information, calling people and stuff. So hopeful that we can get a working prototype built within the next month or so, and then start utilizing it. And then having non-military personnel take a look at it. I would have liked to have done additional user testing, I think. I did the initial 4. I was really surprised that people weren't using the information panels as much as I thought they would. And I was very, very kind of surprised about how they utilized the wireframe. It wasn't the way I had pictured them using it at all. So I think just in general, now that I've updated the splash screens and I've updated the symbology, going back and doing another round of wireframe testing just with some other group of people to see if now it gets used the way I expected it to be used would be beneficial. This is using yeah, so I did the testing with a prototype simulation. I kind of sped over it a little bit. I built everything in PowerPoint and used the PowerPoint kind of like hyperlink function to jump between different pages. And so that way I could make something that simulated the click function of the website without having to spend all the time of doing all the coding and scripting for the website. So that's what was utilized for the testing, was kind of like a PowerPoint wireframe. And then, are there any potential online security concerns for project? Yes, there actually are. The main concern really is just aggregation of a lot of data. You can go and you can search and you can find where our facilities are located and what they do. But for you to get all of that information in one place, at that point, you're kind of looking at things that maybe become confidential or official use only or something like that. So when the website actually gets deployed, it'll either have to be like local on one of our machines, or I'll have to get with somebody and see about how to kind of make it like military access enabled only, or just talk to our security personnel and see if it is actually a security concern to put up all the locations in kind of one place. So yeah, there's potential security concerns. I just have to sit down with the people who know more about that than I do and see what those might be specifically.
All right, Ryan, thanks for your responses to the questions. If you put your email in the chat, if someone has a follow-up question, they can contact you later.
Thank you.
All right, next up, we'll have Melissa give her presentation. So if you want to go ahead and start sharing your screen, Melissa.
Okay. Can you see my screen?
Not yet. It's working. There we go. Yep.
Okay.
Field of
Okay.
corn.
So my
So-
name is
Yep. Go ahead.
Melissa Kelly, and I work for the Farm Service Agency within the U.S. Department of Agriculture. I am the Agricultural Program Technology Specialist in the Virginia State Office, and my primary duties include assisting county offices with our GIS-based farm records and completing all the state-level GIS work, such as mapping for disaster response programs. So my GIS capstone project explores resilience in agriculture, a comparative analysis of the impact of COVID-19 on agritourism and directly marketed agricultural sales in Virginia and Kansas. So the presentation will go through a project introduction, goals and objectives, previous research, data and methodology, results and conclusions. So the COVID pandemic dramatically affected various sectors, including the agricultural sector. For example, outbreaks at livestock processing facilities created a bottleneck of cattle at market weights. This prevented farmers from being able to move additional livestock to the feedlots, compounding the inability to market livestock. Reproductive cycles started months earlier, continued to produce additional offspring. While farmers were experiencing an inability to market their commodities, grocery stores were experiencing shortages of many of these products on their shelves. Through the pandemic, the Farm Service Agency issued disaster payments to farmers under multiple programs, including the Coronavirus Food Assistance Program. That's as shown in Figure 1. That allowed these distressed farmers to continue to operate until the COVID-induced bottlenecks subsided. This highlighted the need for farmers to explore additional revenue streams that they can pivot to when faced with future disasters. So 2 potential additional revenue streams for farmers who typically market their commodities through traditional channels are agritourism and direct sales. Agritourism is income from recreational services such as hunting, fishing, farm or wine tours, hay rides, etc. Direct sales are edible products, including value-added products that are produced and sold for human consumption directly to consumers at farmers markets, farm stands, U-Pick operations, and CSAs, which are community-supported agriculture. So this study aimed to assess the impact of the COVID pandemic on agritourism and direct sales farming operations in Virginia and Kansas, evaluating their resistance amidst the pandemic challenges. So this study investigated the spatial autocorrelation between agritourism and direct sales, specifically using the percent change in the number of operations per county from 2017 to 2022. And this study then used a multiple linear regression analysis to predict the relationship between agritourism and direct sales operations and independent variables, COVID case rates per county, median income per county, and the rate of female producers per county. Reviewing previous research into the topic, trends in agritourism and direct sales were first considered. Agritourism clusters are observed on the exploratory spatial analysis maps in Figure 2 for both 2012 and 2017. Clusters are situated in the Midwest and close to New York City. Direct agricultural sales clusters are observed in Figure 3, with the clusters in the Northeast, on the West Coast, and in the Great Lakes region. Additional research into the factors influencing agritourism and direct sales found median household income had a significant positive effect on the number of agritourism operations within counties in Tennessee. Similarly, a significant positive effect was found on the number of agritourism operations in Virginia counties with a high median household income. Research into gender dynamics in agritourism and direct sales studies did find different conclusions. So one study found a decrease in agritourism farms with a high number of women-owned operations within a county. And then another study reported that counties with a large number of female operations are associated with an increase in agritourism, but a lower number of farms with direct sales. So research into the resilience of agritourism and direct sales during COVID found direct sales of agricultural products to consumers expanded through the pandemic. A study in Northwest Arkansas showed small-scale farms were more agile and able to quickly adapt by implementing strategies such as online ordering and delivery. And a study in North Carolina showed resilience in the agritourism industry as operators quickly adopted strategies such as online ticketing. There are knowledge gaps that exist in the previous research. There's conflicting findings regarding the impact of the number of female farm operators within a county on agritourism direct sales operations. There also needs to be an incorporation of COVID-related variables into analysis to shed light on the resilience and adaptability of agritourism and direct sales operations in the face of this challenge. So the release of the 2022 Census of Agriculture on February 13th of this year presents a unique opportunity to address these gaps as the first set of comprehensive agricultural data to be released since the pandemic. Several data sets were used in this analysis, including the Census of Agriculture. In this study, the spatial autocorrelation analysis utilized this percent change from 2017 to 2022 in the rates of agritourism and direct sales operations per county in Virginia and Kansas. The 2022 data was utilized to calculate a percent of operations with agritourism for each county, which served as the dependent variable in the multiple linear regression analysis. Additionally, a second regression analysis was conducted using the percent of operations with direct sales per county as a dependent variable, also based on 2022 data. And the rate of female producers was also calculated for each county and included in both regression analysis. The Census Bureau Tiger line shapefile data for Virginia and Kansas County boundaries was exported as shapefiles from the national data set and utilized to generate the contiguity matrices necessary for calculating Moran's I for the rate of agritourism and direct sales farming operations per county. The Centers for Disease Control and Prevention weekly COVID cases and deaths data set provided a time series record of the reported COVID-19 statistics, capturing the impact of the pandemic on a county level scale. And the total population field from the decennial census was used in conjunction with the cumulative COVID cases to calculate a rate of COVID cases within Virginia and Kansas counties. And the rate of cumulative COVID cases through December 28, 2022 was utilized as an independent variable in the two regression analysis. The median income from the American Community Survey was utilized as an independent variable in both regression analysis. So in GeoDoc, contiguity matrices were created for Virginia and Kansas to establish which counties are neighbors, as shown in Figure 5 and 6. To maintain a manageable scope, the analysis was limited to these states rather than nationwide. These states have similar number of counties, but some differing primary agricultural commodities. Univariate Moran's I was calculated for the percent change from 2017 and 2022 for both agritourism and direct sales data sets. Bivariate Moran's I calculations and scatter plots illustrated the spatial autocorrelation between the rates of agritourism in a county and the rates of direct sales in the neighboring counties for 2022 and vice versa. So Lisa cluster maps generated illustrated both positive and negative spatial autocorrelation for the percent change of agritourism per county and direct sales per county. And two multiple linear regression analysis conducted utilizing RStudio. The result predicts the relationship between the independent variables COVID case rates per county, median income per county, and the rate of female producers per county, and the dependent variables percentage of agritourism and direct sales operations per county in 2022. So first, the results of the exploratory spatial analysis. I first reviewed the spatial autocorrelation of operations with agritourism per county for each year before the percent change from 2017 to 2022 for the variable. In almost every instance, the spatial clustering is much stronger for the individual years versus the percent change. In Figure 9, the Lisa cluster map shows the percentage of operations per county in Kansas with agritourism receipts in 2017. Figure 10 depicts the clusters of agritourism in 2022. And then Figure 11 is the percent change from 2017 to 2022. The calculated Moran's I value of 0.168 for 2017 and 0.223 for 2022 suggests a stronger degree of spatial clustering in 2022. And the Moran's I value for the percent change from 2017 to 2022 of negative 0.063 indicates slightly negative spatial autocorrelation. The exploratory spatial analysis for Virginia agritourism shows similar results with less spatial autocorrelation in the percent change from 2017 to 2022 in agritourism than in the individual years. As a whole, Virginia did exhibit less spatial autocorrelation than Kansas, and the calculated Moran's I of 0.062 for 2017 and 0.085 for 2022 suggest a very slight positive spatial autocorrelation for the rate of agritourism. The Moran's I value of 0.038 for the percent change from 2017 to 2022 indicates even smaller level of spatial autocorrelation. So the analysis for Kansas direct sales in 2017 and 2022 showed the strongest level of spatial autocorrelation in the study. The calculated Moran's I for 2017 was 0.629 and 0.604 for 2022. However, the Moran's I for the percent change from 2017 to 2022 was a negative 0.048. So conversely, Virginia direct sales showed very little spatial autocorrelation. The calculated Moran's I of 0.045 for 2017 and 0.005 for 2022 suggest a slight positive spatial autocorrelation. And then the Moran's I value of negative 0.02 indicates a minimally negative spatial autocorrelation. So considering the bivariate analysis, the calculated Moran's I of 0.323 indicates a positive spatial autocorrelation between the percent of operations per county with agritourism receipts in 2022 and the lagged percent of operations per county with directly marketed sales, as shown in figure 18. The Moran's I value of 0.236 also suggests a positive spatial autocorrelation between the percentage of operations per county with directly marketed sales in 2022 and the lagged percent of operations per county with agritourism receipts. So Virginia differed in the bivariate analysis with a significantly less spatial autocorrelation. The Moran's I value of 0.012 suggests slightly positive spatial autocorrelation between the percent of operations per county with agritourism receipts in 2022 and the lag percent of operations per county with directly marketed sales, as shown in figure 20. And the calculated Moran's I of 0.039 suggests slightly positive spatial autocorrelation between the percentage of operations per county with directly marketed sales in 2022 and the lag percent of operations per county with agritourism receipts in figure 21. So 2 multiple linear regression analysis were completed using independent variables, COVID-19 case rates per county, median income per county, and the rate of female producers per county. And the dependent variables, the percent of operations with agritourism receipts and direct sales per county in 2022. For this analysis, a challenge became the lack of normality revealed by the descriptive statistics in the percent of operations with agritourism receipts and direct sales per county variables. Transformation of the data did not resolve the distribution, but removal of outliers did improve the normality. And the analysis proceeded with the understanding that all the assumptions of multiple linear regression had not been met. The resulting coefficients of the agritourism regression analysis are shown in the estimate column of table 1, with the resulting equation displayed in figure 22. Variables not determined significant were removed from the equation, and the resulting coefficients of the direct sales analysis are shown in table 2, with the resulting equation displayed below in figure 23. So in conclusion, this study aimed to provide insight into the dynamics of agritourism and direct sales farming operations in Kansas and Virginia, particularly in the context of the COVID pandemic, to identify potential revenue stream diversification strategies for producers. The univariate LISA cluster maps for the percentage of operations per county with agritourism and directly marketed sales indicate there were no significant shifts in location of clusters from 2017 to 2022. There was notably no significant increase in high clusters of agritourism or direct sales in 2022 as compared to 2017. Additionally, this study predicted the relationship between agritourism and direct sales operations and independent variables, COVID-19 case rates per county, median income per county, and the rate of female producers per county, with the mentioned normality assumption not fully met. In both regression analysis, the cumulative COVID cases and median household income per county coefficients rounded to 0. And the agritourism regression found the percent of female operations coefficient to be statistically insignificant, while the direct sales regression found the percent of female operations to be statistically significant and have a coefficient of 0.2. So that concludes my presentation. Are there any questions?
All right, Melissa, thank you very much. Great job. While we're getting ready for folks to ask some other questions, I'll kind of start off here. So given what you've discovered with your analysis, and let's say you have a lot of resources, I'm not going to define what those resources are. You can just sort of make that up on your own. But if you had a lot of resources, given what you've uncovered here, where would you sort of direct those resources to help agritourism grow in either state?
That is a good question. So I think in Virginia, we found that things were much more distributed. There wasn't as much pattern as there was out in Kansas. Out in Kansas, I think you could easily probably direct your resources towards the areas that you could see there was direct sales and agritourism. The western side of Kansas definitely lacked both of those. There is not a lot of agritourism or direct sales. So I don't know that I would direct any resources towards that. I would definitely direct them towards the eastern side of Kansas if it based off of what this study showed.
All right. Thanks for your response. Looks like there's a couple of questions for you there.
Okay, let's see. Okay, so that says, I sheepishly admit that I haven't known anything about agritourism. Has this been a thing for a long time? And can you making a project public help this become a solution for some struggling farms? Agritourism has absolutely been a thing, and I think it's been growing for a long time. I worked before becoming the agricultural program technology specialist, I worked in a USDA county office for 15 years and definitely saw growth in that field. I know in Virginia in particular, we've had an explosion of like vineyards and people like utilizing that as an avenue to diversify their revenue. And that my idea was to hopefully see patterns of where maybe we could say like this would be an area that could support agritourism growth, or there was some ties to that. So but no, we absolutely have seen a growth in agritourism, at least in Virginia here, for sure. And then Anthony Robinson said, this was a very interesting project. What would you suggest for a follow-up study to yours? What problems should another capstone focus on? I think adding more variables and approaching the regression analysis differently is what I would do as far as a follow-up for the capstone. My variables didn't account for a lot of the variation in the dependent variables, so definitely expanding the variables and looking at a different type of regression.
All right, Melissa, thank you very much. If you could put your email in the chat window so folks can contact you if they have a follow-up question, that'd be great. And next up we have Josh. So Josh, if you want to start sharing your screen, see if we can get you set up here. All right, we see your PowerPoint.
All right. So good afternoon, everybody. My name is Josh Argento, and I'm going to be presenting my application I created for our dispatch team at the Harris County Toll Road Authority, or HECTRA for short, because that is a mouthful to say. A little bit of background about the Harris County Toll Road Authority. We're located in Harris County, Texas, so pretty much the Houston, Texas area. It's one of the larger counties in the United States, and the Toll Road Authority maintains roughly 131 miles, centerline miles of roadway. If you include all the lanes, it's closer to 800 and some miles. We have 21 field inspectors and three managers. So we rely heavily on third-party contractors to help out with incidents on the roadway, since it is such a massive system. The toll road does about 2 million transactions a day. And if you were to actually see Harris County or Toll Road Authority, HECTRA, as if you were to put that on like the global GDP, they would rank about 25th or so. So major organization, very busy, a lot going on. So for this project, one of the things I was tasked to do was come up with a more efficient way for our dispatch team to get these assignments out to the guys, the inspectors in the roadways, so that we could speed up response times and increase, overall a better experience for the folks that are using the toll roads. So I'll go over the original process here at first, just to show you what we all started with. So yeah, we have a dispatch team that sits in the office. They would get phone calls from inspectors driving on the roadways. They would jot that down on paper. Then they would proceed to do a couple different manual processes here. So they would text or call whoever would be assigned to this project that they just jotted these notes down on. They filled out a Microsoft Access database form, and then they would manually write up emails as well. So you have 3 different manual processes here that took up time. They weren't always accurate, typos and things like that. So the team definitely wanted to integrate GIS technology to help make this better. So after they went through this process, they still weren't finished. In order to get status updates and to close out incidents that were in the field, there were multiple emails back and forth, more phone calls that were made, just scrolling through inboxes and chasing down the people who had worked on these assignments. So once all those updates were made, the inputs were manually put back into Access database. And it was at this point that any past notes that were taken were lost because they had to overwrite the note section in that for that particular incident. And then when a report needed to be run, the table was exported into Excel. So the cons of this process, totally cut off from any sort of GIS technology here. The closest thing they had were basically addresses in the field, but I mean, there's no way anybody could visualize that just by looking at stuff on a spreadsheet. Again, there's no way to track any sort of metrics without chasing down a ton of emails, jotting down extra notes and things like that. Nothing can be created on the fly. And issues couldn't be recorded in the field. Like I mentioned before, everything was reported into phone calls through dispatch. So after sitting down with the dispatch team and the people in the field, we came up with some objectives for this project. First, we wanted faster response times. Like I said before, it's a safety issue with some things on the road, so they need to get reported and responded to quickly. It has to also deal with the experience that the people who are paying for these tolls have on the roadway. So the better experience that we can give them, the better. Increased accuracy and consistency. So you can imagine if people are jotting things down on paper and then trying to write them up quickly as well, there's going to be some typos. There's going to be variations of the same things, like some people might abbreviate street, some people might actually spell it out. So just to keep things consistent for reporting purposes, we wanted to try to make things as uniform as possible. Another big thing, of course, especially review the data so that everything can be seen on a map. This was pretty important because the managers needed to see where the problems were in the field. If there was a certain area of the toll road that was experiencing more problems, then maybe they can hone in on that, figure out what's going on. The other thing would be to keep track of the job statuses. Like I mentioned, it's a lot of back and forth phone calls, searching through your mailboxes, and these dispatch folks are getting emails from not only the 20 field inspectors, but also the third-party vendors that they're using. So their inbox gets flooded pretty quickly, and it can be hard to find some things. So to be able to view these things on the map and track the status of them by symbology was another big thing. And we also wanted this to be usable in the office and in the field. A lot of times on the weekends, the dispatch team is not working on the weekends, so someone is always on call, and that's usually the guys, the inspectors in the field. So if they're out on a job and they have to report something, we wanted them to be able to do that mobily as well. So the improved process that I came up with, wanted to use ArcGIS, Esri applications so that they could record things mobily and on the desktop. The first solution that I looked into was Workforce, but I quickly realized that although Workforce, at first glance, seemed like it'd be a pretty good fit for this because it's essentially a program designed for people to dispatch work to others in the field. It's not very customizable. So we have a lot of things that we already had in place, of course, with all of the access database verbiage and things like that we couldn't pass on to this. And the goal of this project was not to take away anything, but to add to what they were already doing. So we had to switch directions, and still using the same workflow as Workforce. I combined a couple of different applications that Esri also offered. Mainly field maps for the people in the field to be able to use tablets or phones to drop points for assignments and things like that. And then Survey 123 to kind of take over the form filling out that they were using in the Microsoft Access. This was chosen because after doing a lot of research on field capturing, things like that, it's good for using drop-down menus and calculated answers and things like that to help the user have a faster response time and not have to manually type things out, and kind of lead them in the direction of capturing the data in a uniform fashion. And then Experience Builder would tie together Survey 123 and any web maps that were used, and dashboards as well that can show the progress and things of the assignments. All this data is actually stored in our SQL Server database in-house. Nothing is this data isn't actually stored out on the cloud because a lot of the tolling information has people's transaction data and addresses and things like that. So any sort of data that is used is kept pretty close to the chest and in-house. The goal also to be to eliminate all of the manual emails that are sent out. So that's where webhooks come in handy. And for webhooks to send out email alerts, I'm going to be using Power Automate. So with that data being stored in SDE, it can also be used for other applications like I mentioned before, a dashboard. So to fix the problems we had earlier, now this information is fully integrated with GIS technology. Data captured can be viewed in dashboard, and so we can track metrics and create charts in real time. And using field maps, the issues can now be recorded in the field. And all this is done using the ArcGIS Online Enterprise licenses. So Survey 123 is basically the heart of this application. Like I mentioned earlier, it's how the crew can fill out the information. In this demo here, you can see a recording I did of how quickly you can go through and just pick what's going on, jot down any notes. As I mentioned before, the notes were lost, but with this, you can add a second note or third or fourth, however many you need. And then you can go back and review the history of this process, depending on what the status is. And all of that is done not using a lot of heavy coding, but with Survey 123 Connect, there's an XML spreadsheet. And as you can see here, once you hook up your feature to it, you just select the type of question. So if you want a drop-down question or a select multiple question, that's just done in this column. And then you just hook it up to whatever field you need to. And as they're answering these questions in the form, it's actually getting wrote to the attribute tables for the point. And if you do want to add some calculations and things like that, you can, but it's just a lot of simple things like if statements and concatenations, things like that. So as far as visualizing this data and being able to track metrics and things, I created a dashboard here. So as you can see, we have the status symbols at the top of the assignments. You have different charts in here that the user can click on and filter down data. There's a list of who the projects are assigned to as well. You'll see here, I have some projects open past 20 days. So I pulled in some older projects that were still open from the Access database. And so those are listed here so that the managers can keep an eye on things that may be taking longer to be expected. So the second page of this experience builder is, here's another demo of how they're actually dropping the points. So I have a web map that I have all of Hectra's assets that we had previously created pulled into. And then what is happening here is the dispatcher is creating a new dispatch assignment point. And so survey 123 is actually linked to this point. So you'll see it here on the side on the right side. So as they click on the point, the survey for that point comes up. So you're not having to switch back and forth between different applications. The dispatcher or the field inspector can fill this out quickly on a desktop. And so even as if a call is coming in, it's a lot easier to do this than fill out the spreadsheet that they were doing before. And then once they hit submit, the status of the point will change to whatever color. And then you can also go back and click on a point at, like, say, the next day or so, and then the survey will come back up and you can change the status, add more notes, add pictures if you need to, things like that. The last two tabs here, assignment list and completed list, are just the attribute tables for these points. Again, the idea was not to take away anything from this workflow, but add to it. And since they were already used to using these spreadsheets, the feedback I got was they would like to keep them involved with it. So that was one of the requests that we had through discussions. And then here is a screenshot of what the application looks like on field maps. Again, you can drop your point, and then I have a link built into the pop-up for the point that will take you to survey 123. So in the mobile device, it's not necessarily one-stop shop, but it does give you a link that will automatically open up the application and just makes it a little bit easier to use in the field. So in project summary here, for the project timeline, this project is still ongoing. I'm getting a lot of feedback from the users in the field. We've been having meetings every Tuesday, and the idea is that they are trying these out in the field. Currently, the dispatch team is still using the old methods, but they're also doing this as well. So old methods is still a backup until everything gets ironed out and everyone feels comfortable totally going live with this. But they are actively putting things in and using this as if this has already gone totally live. So yeah, I also foresee from my experience with getting feedback from everyone that this is always going to be an evergreen changing project, because you always have different scenarios that come up or different ideas that new people coming in to the team will have that could benefit to make this a faster process or an easier process for everyone to use. So yeah, I don't. As far as the email automations, I'm still working on that part, but that should help as well cut down with different people receiving emails that aren't supposed to, you know, and everyone knows whatever they're assigned to, they're the ones that will get that email, and everyone can kind of filter out a lot of the noise that they had before with all that stuff. As far as the goals that I met so far, I would say that as far as integrating the GIS technology, that's taken care of. Like I said before, you can't really get too much information from those besides the addresses. In order to get the old points in there, we did some georeferencing, but again, some of those addresses weren't spelled correctly or had variations, so it was a little difficult to get some of that stuff in. But now, when you drop the point, you know exactly where it is. You have coordinates, things of that nature, and it can show up on the map. So as far as that part goes, we completed that task. Mobile, using this application in the field is another thing, using the field maps that we accomplished as well. And also being able to use the dashboards to sift through the information quickly, see what's out there. Don't know if you noticed, but when I showed the screenshot of the dashboard, there were over 500 incidents that had been completed in the past 30 days, which was a huge eye opener for me. I had no idea that Hectro was that busy with incidents, and those incidents can range anywhere from mowing grass, changing light bulbs and street lights, to a car wreck that involved a car. So a lot of different variations there, but nonetheless, still a very busy organization. And I would say that all three main goals that we had were the problems that came up with the original process had been completed. As far as stats, like I just mentioned, that's one thing that we can track using the dashboard. So it was definitely an eye opener for myself and for some of the managers, how busy everything was going, and that's also a testament of the original process they were using. Sometimes you couldn't see the entire big picture because of what tools they were using before. But I think the stats do verify that a lot of the workers are using it. They've given good feedback for the development of this project, and that they are happy using it. So moving forward, like I mentioned, still having meetings with the team, and that will probably end after the email automation is set up, and we get all of the formatting and templates worked out for that. We're also going to try to integrate these points created into a management software that we use that tracks cost and work orders and things of that nature. So there's talk of figuring out a way to integrate this data into that, which is not it's a software that uses GIS, but it's not created with Esri, so it's on a different license. So there needs to be some work to figure out how to integrate that data, but that's something that's on the horizon as well. And then for now, it's just been our dispatch team and the incident or the field inspectors that are using this application. Eventually, we'd like to get some of the third-party managers involved as well, so they can report issues that they see on the roadway that they would normally have to call dispatch in as well and let them know, hey, we see this, we're going to start working on it. So that'll also, again, cut down some response times and things like that. And then, again, I mentioned the emails as well, are made up and running. That's it. Thank you.
All right, Josh, great job. Very practical application. Looks like you've got 2 questions in the chat window. If you could
Sure.
take a look and respond, that'd be great.
Okay, what type of issues are managed by your application? Is this time of submission record, as well as updated submissions, and can this information be used to track estimates how quickly issues are addressed on average? So we do, as far as the attributes that are recorded, there is a start date and a completion date that are recorded. One of the other things that we have in there for calculations is depending on the priority. So we have P1, P2, and P3. P1 projects are emergencies. They have to be completed within 24 hours. And then it kind of trickles down from there as far as it's more of just like a high, medium, low priority thing. Let's see, and then, so yeah, that's kind of how that's managed. And then the main metric that they are live tracking is the issues that are open, longer than 20 days. There is also a pause that we have in there as well. And whenever someone puts in a pause, a required note field comes up of why it's being paused, so that we do have some details and things like that in there. But as far as being able to grab something and just like on the fly see how long it's been open, you would just have to look at some of the attributes of when it started and hasn't been yet.
All right, Josh, thanks for your
Let's
response.
see. Okay, yeah.
Oh, sorry.
The dashboard, the data is uploaded to the dashboard in real time. So the field map is editing creating or editing, I should say, the assignments in real time, and then that is being pushed right into the dashboard. So yeah, if the dashboard refreshes every couple minutes, and then you can see what's going on there. I don't have any cost saving estimates. And as far as saving time, no real like tangible numbers, but I will say that I have set in with some of the dispatch folks as they were recording these incidents, and it does cut down on them actually getting the information out a little bit. But what really is saving them a lot of time is not having to sift through all these emails and going back and forth with the contractors as far as what's going on right now. We have they call it a hectare number, which is basically the work order that everything's tied to. So if they just search that number, it can be filtered right into the map. Then you can see the pictures, again, the status or any attributes, start dates that they can do. So they don't have to try to call these people, track them down, see what's going on. Everyone is the time saving is a lot for the dispatchers, because now it's not all on them to report these issues, because now we've given the people in the field the capability of doing it as well.
All right, thanks for your responses. If you could put your email in the chat window in case someone wants to follow up, that'd be great.
Sure.
And next up, we have Catherine. So if you want to start sharing your screen.
Hey, let me try and get this up. Okay, can you see my screen?
We can, and we can hear you, so you can start whenever you want.
Perfect. Okay, I am Catherine Brown, and this is the first half of my capstone Virginia Karst mapping application, bridging the gap between scientists and stakeholders for risk assessment. This project aims to create a web application to view a karst geodatabase from Virginia Energy Geology and Mineral Resources Program. I used to work within that program and was there for the start of this ongoing project, but now I work as an administrator for the whole of Virginia Energy. So far, they have completed phase 1 of 3, and this project may eventually increase in scope. So I've been keeping that in mind as I've been looking at how I want to create this application. Okay, so what is karst? Karst is an area composed mainly of carbonate bedrock that exhibits features such as sinkholes, caves, springs, and disappearing streams, and that's due to bedrock being dissolved by groundwater. In this photograph, I have a pretty piece of karst here, pretty karst feature. This is Grand Caverns, which is a show cave, and this is showing a place where we have slightly acidic groundwater that flowed through limestone bedrock, dissolving as it moved, and created this cave. Where does karst occur in the United States? This is a map of the continental United States. Most states do have some sort of karst features. Here in Virginia, we have both the western portion, the Valley and Ridge Province is the main area of karst, but there is a little bit to the east, and that may be added on to this project later. Most people think of caves and maybe sinkholes when we're talking about karst, but karst is more than that. Karst has voids under the surface that may not be seen, so those caves. And sometimes we know about those caves, sometimes we don't. But when one of those voids or caves collapse, a sinkhole may appear at the surface. This can act as an opening to groundwater for the area, which is a major issue. Karst can not only impact humans, but it can also be accelerated by humans. Storm wastewater flow changes and construction and pumping of groundwater, all with the increase of populations, can also increase the rate of limestone dissolution. This can lead to issues such as sinkhole collapse. So how does karst appear? This is kind of a dramatic example of karst. This is a sinkhole in Clark County that collapsed due to groundwater being pumped out of the area. And then I also have an older aerial shot where you can really see some pockmarked sinkholes where obviously this is a karst area, and this is in Virginia. So those are the dramatic textbook examples, but this is what karst is more likely to appear as when you're out in the field. And this is state geologist Matt Heller standing in a sinkhole in the Valley and Ridge Province. Karst and sinkholes aren't always as obvious. While it's not as obvious, this area has potential for sinkhole collapse. And since this is a sinkhole, this will act as a conduit to underlaying the groundwater. So karst seen in LiDAR. This slide shows sinkhole polygons and points over 1 meter LiDAR, high resolution. This high resolution LiDAR has only been available in Virginia since 2010. So our mapping has changed with that. Now we can see much more sinkholes by looking at LiDAR. However, as you're looking at that sliding on and off, you can see some sinkholes have been mapped that you might not be able to visually see on the LiDAR. That's because Virginia Energy utilized a model builder to detect sinkholes within the LiDAR. This is a new way of mapping karst and is only currently being done by a handful of states. So where is karst in Virginia? As I mentioned, we're going to focus for this application on the western portion of karst. This is the Valley and Ridge geologic province. There is a little bit to the east. This is the Chesapeake group in the coastal plain. For now, the LiDAR mapping techniques, we haven't seemed to be able to get that to work for those. I'd like to see eventually this karst application go statewide, but for now, I'm developing it for that western area. So currently, what data do I have? This is what I currently have turned in. As I said, this is an ongoing project. So I have 18 USGS quadrangles, which is a typical measure size that is used in geologic mapping. And I have that for now for the 18 quadrangles. I plan on having this application expand as the project moves on. Okay, the final extent of the map area. So in bold, I have that phase 1. Phase 2 should be turned in this fall. That's going to include the couple quadrangles north of phase 1 and then some more in the south. Phase 3 will be delivered upon after the completion of my capstone in 2026. The biggest thing I want you to see is that this is a very, very long, skinny map. Prior, most of these geologic maps were put into PDFs. They took the GIS out and basically made a static item. In the case of this cannot really be displayed as a static PDF or printed map. So that's why Virginia Energy and the Geology and Mineral Resources Department was looking for someone to put this in an application that would be user friendly. Eventually, this is going to cover over 50 USGS quadrangles and all of the area of I-81. Okay, karst is a geohazard. There are 2 potential hazards associated with karst: sinkhole collapse and groundwater contamination. Here in Virginia, we see sinkhole collapse, and especially in damage to roads, buildings, and other property. VDOT has repaired approximately 500 sinkhole damaged sections of the road in the past 30 years. Sinkholes are of a big concern to VDOT and cost a lot of money, obviously. We also have several documented cases of sinkhole collapses damaging structures. So this also impacts construction. In addition to that, one that's kind of not as obvious is the groundwater contamination. Sinkholes and disappearing streams act as a conduit to allow pollution to enter the groundwater. So that could be anything from trash or any sort of pollution. And this area surrounding I-81 is of major concern because I-81 is a major road through Virginia that transports hazardous materials and runs through the heart of Virginia's Valley and Ridge province. So knowing where those sinkholes are, if there was a potential spill of pollution, would be very important, and having that at hand. Okay, so why publish karst in Virginia? One of the big figures that I saw when I was researching this is that karst damage causes approximately 300 million in damage a year in the United States. That's for all the United States, not just Virginia. And as I was looking into it more for Virginia specific, Virginia's 2023 Hazard Mitigation Plan by the Virginia Department of Emergency Management acknowledges karst as a risk, and it did list it as low, but that's in comparison to floods and hurricanes and whatnot. And they said that they could not fully estimate karst damage and karst risk for Virginia because they did not have mapping. So basically, they do not have this mapping, so they can't adequately do their risk assessment and planning. Currently, karst mapping at this scale of detail is not available to stakeholders. They would typically, if they wanted this mapping, they would have to sort through multiple sources and to get that geologic mapping, and they wouldn't necessarily even know where to go looking for it. It's not well organized. So again, this application is looking to solve that for them. Okay, and a little bit more on why I need to publish Virginia karst. Karst mapping could impact zoning, construction, and water management. Karst focused mapping has been requested by multiple Virginia agencies. As I've been working on this project, I have gotten a lot of feedback that they're ready for this almost yesterday. I had just this past Friday, I had multiple people asking for this project. Karst data is also of significant interest to the scientific community, and the USGS has been in a decade-long push to have all these karst features mapped at a national level. I'm hoping that this karst viewer can almost serve as an example of how we could do this, and hopefully integrate other states and especially even the rest of Virginia. Okay, so I wanted to kind of give you an idea of what this karst data looks like. It is mapped at a 1 to 24,000 scale. So this is just a portion of a USGS quadrangle. This is a lot of data in a very small area. So again, it can't really be printed. And I have an entity relationship diagram. This is done in the USGS Geologic Map Schema, or GEMS. It's well developed for a geodatabase. It has many relationships and foreign keys. I intend to leverage that in the creation of the CAR stack. And here's an example utilizing that GEMS schema. There is a lot of information for each point. So again, this would not be good for a printed map. In this case, this sinkhole has things like existence confidence, whether it's probable, location confidence, how confident we are on where it's located. And then every single item has a citation within the attributes that leads to the data sources table. So that data source ID. Okay, we do have some sinkhole layers. Well, we have a sinkhole layer on our Virginia Energy REST services. That is the yellow layer that was mapped by stereoscopic viewing by David Hubbard in the 1980s, 90s, and I believe he put out his last one in 2001. This new LiDAR detected version has a whole lot more sinkholes being identified because they're utilizing Model Builder and looking for those depressions. And you can see that the black layer over the yellow layer here. Government stakeholders, like I said, I am with Virginia Energy. I will say that even within parts of Virginia Energy, they don't realize that this data exists, and this could help our mine land reclamation team in determining if an area is a mine or a sinkhole. In addition to that, both DEQ and VDOT have been very excited that I'm putting this application together. Obviously, Virginia Department of Emergency Management specifically has said in their documentation that they don't have adequate mapping. And beyond that, county planners, environmental consultants, I've heard from, all want to have this data and easy access to it. Okay, potential benefits to citizens. Roads that are planned to avoid sinkhole compromise, construction and zoning that is cognizant of the sinkholes, and water sources. Hopefully we can zone that a little bit better to protect the water sources from pollution. Project goals. I want to create a very user-friendly mapping application to communicate Virginia's karst geohazards to the public. So I realize that these people not only may not be familiar with karst, but they also may not be familiar with GIS. So I'm very much concentrating on a user-friendly experience. I also need to create a karst feature data set and feature classes on Virginia Department of Energy's Geology Enterprise Geodatabase. That should serve not only the Geology and Mineral Resources Department, but also allow the rest of the agency to access that data. I also need to publish web layers of the karst hazards to get them out onto the web to support other stakeholders mapping projects so they can pull them in directly. Just on Friday, I attended the Virginia Geologic Mapping Symposium, and we had a session on the karst project. And again, I got lots of feedback that they were excited for this and items that they wanted. And in addition to that, we had a breakout session where we had surveys on what members were looking for in this type of mapping. I'm working on getting this data, but unfortunately this was the past 3 days. So I will have more of that, and I plan on incorporating that into my application. Deliverables. I need to have an enterprise geodatabase feature class of karst features and related tables. I want that published out to REST services. I want an experience builder application that's accessible to the public, and I plan on having an explanation like user guide in the format of an ArcGIS story map. Since this is all happening in an existing system, there are policies that I have to follow. All this data that's available to the public must be hosted on VITA servers. VITA is the Virginia IT agency, and we are legally required to follow their direction. All of the enterprise geodatabases must be administrated by a member of the IT team. The application must be developed using Virginia Energy ArcGIS Online or enterprise logins. And eventually the application has to be downloaded using ArcGIS Developer and hosted through the Virginia Energy website. I need to add a Virginia banner and Google Analytics. So methodology. I'm already working on the identification of stakeholders and their needs, development of a user guide and background information. The next thing I need to be working on is setting up the karst feature classes and non-spatial tables in the Geology SDE, then publish the REST services, develop a web map. From there, I can pull that into Experience Builder and build the application. Then I'm going to put that out to my user group and edit as they need. And from there, I will be downloading all of that with the required elements to the website. So here's my timeline. I have gone ahead and done, I guess, the research portion. I've started meeting with user groups and getting an idea of what everyone wants. I will be completing a rough draft of the ArcGIS story map this month. From there, I'm going to go ahead and do the enterprise geodatabase, and then get the draft of the application to the users for feedback. In the end, I plan on being done in March 2025 and to present at Southeast GSA meeting in Harrisonburg, which is right at the center of my study area. So in conclusion, I liked this quote. Scientific data are not taken for museum purposes. They are taken for a basis for doing something. If nothing is to be done with the data, then there's no use in collecting any. The ultimate purpose of taking data is to provide action or recommendation for action. In the case of this karst data, it's kind of sitting there and it's wonderful data that a ton of people can use, but I have to somehow get it to them in a way that they can utilize and discover. And that is it for me.
All right, thanks, Catherine. Great job.
Yep.
Looks like you have a question in the chat window.
Sorry. That said, I'm sure, as you know, karst data is often related to radon risk. I was curious if that aspect might be worth noting as well. That was actually something that we discussed on Friday. We do not currently have a very good up-to-date radon map, and that was something that was requested that we create. And when I say we, it would be the Geology and Mineral Resources program. So I don't have that currently. And in fact, another feedback that I got was that they would eventually like to see multiple risks on the same map. Again, I'm going to be guided by the users here. And I think that that would be something that we would add on later. I'm hoping that I can make this application flexible enough that it would meet everyone's needs.
I have a follow-up question here. It may not be related, but have you been in contact with any of the grottos throughout the region? I know there's some fairly well developed grottos that do a lot of caving, and I don't know if you relied on their input at all for this.
They were involved in the original geodatabase, and they specifically requested that we do not publish their data. They are concerned with people going into caves and not and possibly damaging them. So yeah, I think that this would be good information for them, but I don't really want to publish, for instance, cave entrances.
Sure. Okay. I have another question in the chat window.
I'm not seeing another one. I see Beth.
Yeah, there's one from Josh. Oh, he actually mistakenly sent it to me. Let me read the question for you. Do you currently have a way or plan on having a way to take this data and import it into a geologic mapping software. It would be interesting to see how this data correlates with mapped groundwater levels.
I plan on publishing this with REST services, and that was one of the things we were talking about. Currently it's available as a download. I have shape files and I have a geodatabase, so very Esri based. I plan on probably adding to that at least some KMZ files. I would be interested, and that's probably something I need to hear user feedback. How do they want that? And what can I put out with those REST services to make it useful to them? That's a great point.
All right, thank you very much. Catherine, if you could put your email in the chat window in
Yep.
case someone has a follow-up question, that'd be great.
Okay, thank you.
And next up, we have Tim. Tim, if you want to go ahead and start sharing your screen, we'll get your presentation rolling here.
Yeah, sure thing. Share. Where is the share button? Right there.
Bottom center of the screen.
Okay.
All right, we see your presentation and we can hear you. So whenever you're ready to go, that's.
All right, thank you very much. Welcome everyone to my capstone presentation of wildfire and community vulnerability in the wildland-urban interface. My study area specifically was Missoula County, Montana, where I live. And I'd like to quickly thank Dr. Erica Smithwick for being such a guiding force in this project design and overall guiding my actions. Tonight, we will tell you a little bit about the project background. I'll tell you specifically my research questions, dive into my methodology, show you my results, and discuss what those results might imply, how we might take that for the future, and then I'll call for questions at the end. Okay, so first we have two graphs of the national wildfire trends. And this is nationwide, it's not specifically Missoula County, but nationwide we see a lot of variability in the number of incidents per year on the left-hand side. But it's still generally increasing over year. But the number of acres burned per year by these wildfires is, by contrast, starkly on the rise and getting higher every year. Here in Missoula County, we have just as long a history of wildfire in the ecosystems around here as anywhere else in the American West. Here we just see the county outlined in black, and you can see the perimeters from all of the large wildfire incidents from 1984 until 2018. I don't know how well you can see it on your screen, but the perimeters you see with the dark bold red and the hatch marks, those are the most recent fires, and they are also some of the largest. Okay, so Missoula County's social background is we're experiencing a lot of population growth, especially between 2010 and 2020 when I was studying it. But the county population fluctuates annually because there's a university here in Missoula. And as a county, it's a real hub for tourism for a variety of reasons, a lot of outdoor activities. The ecological background is just as diverse. There's many elevations or along all the mountain ranges out here that provide different ecosystems for different species of tree. I have listed here some of the most common stands of forest that you'll see, the western larches. Missoula is very famous for the western larches. And all of it is evolved for the inevitable threat of wildfire. And the wildfire phenomenon contributes to a variety of the plant and fauna wildlife you see out here. So I've mentioned the wildland-urban interface a couple of times now, and it merits defining because it's not self-evident. The wordy definition is that it's any area where the combination of human development and vegetation have the potential to result in negative impacts on the community. The table you see is a more spatial criteria representation of what that means. And then the image you see on the photo you see on the left-hand side is, you know, an alarming photo of one such WUI, wildland urban interface. So it comes out to 1 house per 40 acres or 6 houses per 2.4 kilometers. The units of measurement in a lot of these documents it's pretty variable because they go back between metric and imperial. But sorry, I'm getting away from myself. This is what the wildland urban interface is. It's the zone where our communities are most likely to be impacted negatively by wildfire. So this brings me to my specific research questions. How has the WUI changed in terms of area and social demographics between 2010 and 2020? To what extent do the mapped social vulnerabilities compare to the existing spatial extent of the WUI categorization? And the third question, what is the influence of social vulnerability characteristics on the wildland urban interface designation in Missoula County? So the first question was tackled just with some comparison mapping, the 2 wildland urban interfaces, the one from 2010 and the one from 2020. So what we see here is the 2010 WUI. The bright yellow is the classic interface. That's like the community we just saw that was bordered by a on fire area, where there's many houses. It's more densely housed, and it's adjacent to wildland. What you see in the darker orangish is when it's more rural, you'll have houses and then like a large property of forested land and then another house. In 2010, the WUI was 751 square miles. And I just described what the 2 categories mean. It's just housing density and then proximity to wildland. So we measured the population growth in these years. Sorry, I'm kind of getting away from myself. I should have introduced my markers of social vulnerability before I had this, but they're going to be on this page. I was concerned with the households that had minors and the households that had senior citizens occupying them, because among others, households with dependent children and households of senior citizens have more trouble relocating, evacuating, just generally reacting to and responding to and a wildfire in their proximity. So between 2010 and 2020, we had a large rise in the number of houses with minors and seniors. Generally overall, we had a lot of houses built in the county, 4,436 new houses. The total area of land also grew. As you would expect, if the community is expanding, there will be more area in that buffer zone, with an additional 135.16 square miles in the county. And then the total population, just overall, we had over 9,000 people move to the county in 2010, or between 2010 and 2020, I should have said. And that brings us to the 2020 layout of the wildland urban interface. So as I mentioned on the previous page, the WUI has grown by 135.16 square miles, which is an 18% increase. That's a lot, you know, might be up here. If we look at, there will be a side-by-side comparison on the next page, but while we have it zoomed in, I want you to look at this area, which is in Seeley Lake, Montana. This area, which has become one large blob in 2010, was 2 still distinct communities with WUI surrounding them. But I'm guessing there was some, you know, smaller houses built, communities built in this area, and that just led to the overall area classified as WUI growing for the 2020 sampling. So we have addressed questions 1 and 2. We have measured that the WUI got bigger, and we have measured that there's a larger population of people some of whom are have markers of social vulnerability. We still need to measure the spatial relationship between those communities and their probability of being in the WUI based on those metrics. To tackle this question, I used forest-based classification in ArcGIS Pro with the census block groups. Yes, sorry, shouldn't have said that. The forest-based classification is derived from random forest classification and regression. Esri has a tool set in the spatial statistics package, which creates a model of what you're searching for. I was searching for the grid code of either WUI or not WUI. It predicts whether a cell will be in the WUI based on your explanatory variables. And I was using these markers you see in the middle as my variables of social vulnerability. So the tool set was trying to build a model of the Missoula County WUI using only these census variables as the explanatory training data. On the right-hand side, I just have the 7 kind of generalized steps of running through a random forest regression or classification. It's kind of an iterative process of telling it to do certain things with your explanatory variables and then seeing what the output is and retraining it with different parameters. Okay, on this page, we can see an example of the random decision tree. We see 3 on this page. The tool set has a theoretical many hundreds of randomly generated decision trees, and it's this random generation of decision trees that gives it the name random forest. So in this example, you can see that the computer is given a training data, like on the right-hand side, it's given the training example, and it sees that example comes with it the 6 markers of social vulnerability that I'm studying. And at the end of that decision tree, it moves from one to the other. It then makes a prediction whether that cell is in the WUI or not. So you see 3 decision trees in front of you, but in the overall tool set, there would be many of these, and they're randomly generated. Not all of the data is used, and then some of the data might be used twice. There's many levels to the randomness to keep it statistically pure. And that's how it gets the name random forest. Okay, so we run the random forest tool set, and it produces this map you see on the right. I should start with what's on the left is the input data that we have that I gave it is the 2020 WUI defined by the Forest Service and the other governmental organizations. I reclassified it so it was either in or out. And then on the right-hand side, you see what the forest-based classification generated as in the WUI based on the census attributes named before. Okay, so we look at what popped out, and what I noticed pretty quickly was that the census block groups were all classified together. In the middle, you see the results, and on the left-hand side, you just see the census block groups of Missoula County. And on the right-hand side, you see how the zoomed-in portion of that map, where you see how the classification ran along the census block group boundaries, perfectly, given the aggregation. So that was something to consider that it'll come back up in the discussion. Another way of visualizing the output from the forest-based classification was for the sameness attribute. This image we have here is the output of the classification. What's in green is values that they had the same WUI grid code after the tool set and from the input data. So it might have been cells that were WUI and were classified as WUI, or it's cells that were not WUI and were classified as not WUI. And it's just another way of seeing that the differences lay in the boundaries of the census block groups. But we can measure the error of this model by dividing the correctly classified cells over the total number of cells multiplied by 100. And I found 67.48% of the cells in this model were correctly classified. The misclassified areas were, I kind of got into this. They were misclassified because they were in a census block group that was predominantly the other way. Okay, discussion of the results. Well, one thing that I need to discuss is the multicollinearity of my markers of social vulnerability. The population density is very closely related to the housing density, and it's closely related to the number of subcategories of people. So I think moving forward, I would have liked to have included related but different measures of demographics. It would have given a more wide-angled view of my data. And I brought it up very briefly earlier, but moving forward, I could run the same methods on the census blocks instead of the block groups. And it's just a finer scale. You can see them on screen. Instead of 87 block groups, there would be 4,000 plus census blocks. But that would there would just be more places for the, more data, more ways for the computer model try and refine itself. And another consideration that I wanted to bring up would be to omit the inner city values of housing density and population density. Because in all of the statistical analysis I was doing, you're really skewing the data, and the innermost census blocks and census block groups are not part of the WUI technically. So using their census data in comparison with all of the others, well, I think it could have been refined if I had omitted that. And thank you for sticking around. I know it's late, but if anyone has any questions, I'd be happy to answer any questions.
All right, Tim, thanks a lot for your presentation. Great job.
Thank you.
As we wait for questions to show up in the chat, have a question I'll ask you about your variables. So, I mean, you mentioned that there are other variables that potentially you could have looked at, or maybe different geographic scales, aggregations, and so forth. But is there anything unique to that area in terms of like tree density or fuel type or something like that would be maybe a better predictor than just looking solely at demographic type of variables?
Oh yeah, the WUI is modeled by the Forest Service and the county and all these other NGOs using fuel model and land class, NLCD data. I just wanted to see if using these social variables, if I could find this relationship. But yeah, the WUI itself is predefined using land characteristics and the housing data.
Yeah, the question with the demographic data is a lot of that is largely correlated to it, and you saw that in the table that you presented. So I was just kind of curious if there was something else that was not census related that would help in your estimates.
Yeah, almost certainly.
Yeah. All right. Looks like you have a question in the chat window.
Yeah, Beth asks how other states, counties, etc. define the MUI. And that definition, it might be discussed differently, but there's an interagency, the National Wildfire Coordination Group, that has kind of the definition, and all of these state groups are defined through that. So I think most other states and counties would have the same definition.
All right, Tim, great job again. If you could put your email in the chat window in case someone has a follow-up question.
Yes, I did.
Great.
Thanks,
So I
everyone.
wanted I want to thank all the presenters for their efforts tonight or today. Great job to everybody. We will have another session tomorrow, starting at 12:30 Eastern. That'll be the last session for our capstone students. So hope to see all of you there. Thanks again, everyone. Great job, and have a good rest of your day.